Hello, I'm John Einberger, Product Line Manager here at Makino. Today I'm going to talk about the Makino A500Z. So first thing first, what is an A500Z? This is one of our horizontal machining centers. It's built from the factory with 5 axes, and it also comes standard with a pallet changer. But let's dive into the details. So let's jump right into the kinematics of the A500Z. That's something that's very unique to this machine and something that offers some clear advantages from a metal cutting standpoint. So if we start out with the Makino 4-axis A61NX as the baseline for the X, the Y, and the Z motion of the A500Z, and add on to that the rotary table-on-table design from our D200Z, the resulting machine is the A500Z. Peeling back the sheet metal, we can see what the kinematics look like. Very unique, particularly in the arrangement of the B axis over the C, with the C sitting at 45 degrees to the linear Z axis on the machine. A little bit closer look at the machine. Again, that's that 45 degree C relative to the Z axis that lies underneath it. If we translate that into the range of motion of the machine, when C is at 0, the pallet top is parallel to the spindle center line. At the opposite extreme, when C is at 180 degrees, now that pallet top is perpendicular to the spindle center line. Note that that C axis goes from 0 up to 180, back down to 0. That's the range of motion of the C, with the unlimited rotation of the B axis sitting on top of C. From a basic spec standpoint, 730 millimeters of X stroke, 750 millimeters of Y stroke, and at C at any angle of the machine, 500 millimeters of Z stroke. One thing to note, that when C is at 0 and that pallet top is flat, you get an additional 200 millimeters of stroke in the Z away from the spindle. I'll call that bonus stroke. That's part of what facilitates the pallet change on the machine, but that can also be used as part of your machining program again when C is at 0. The B axis is unlimited, full 360 degree rotation, and the C, as I mentioned, from 0 to 180 and back. It's an up and back style axis. From a work envelope standpoint, 630 millimeter work envelope. Not coincidentally, the same as our A51NX, and I'll get back to the implication of that a little bit later here today. With a height of the payload of 500 millimeters and payload capacity of 400 kilograms, sitting on top of a 500 millimeter top surface pallet. Where the A500Z sits in the model lineup, being a Cat 40 class spindle machine, sits really on top of our A51NX, A61NX from the 4-axis perspective in the Makino HMC lineup. Let's dive into 3 main areas: cutting capability, cycle time efficiency, and reliability. 3 of the basic design tenets that Makino really focused on with the design of the A500Z. Jumping first into cutting capability. Very high rigidity in this machine. That's one of the basic design ideas that goes around that very unique B-axis over C-axis layout. To back up a little bit, one of the things that Makino talks about, one of the things that we brought to market many years ago, is a stepped bed column design. That's where the linear motion guides on the bed relative to the column for an X-axis movement of the machine are sitting at very different heights relative to each other. The design idea around that, shortening the force path of the cut through the spindle, into the column, into the bed casting, overall effect, increasing the rigidity of the platform. Now Makino in the A500Z took that same basic idea and put it on the other side of the force equation. So again, as that cutting process takes place, that side of the force equation going from the spindle into the workpiece, through the fixture, into the table unit, and again, ultimately into the bed casting, very short, very direct force path. A little bit deeper look inside of the B and the C axes, a couple of things to note. Number 1, the pallet clamping mechanism is the same that we're familiar with the 4-axis Makino product and the A51NX all the way up through the A120NX. The same 4-cone locators that we use, the same standard pallet clamp conformation system that's been part of the design of the Makino HMC lineup for quite some time. Some of the things that we do on that rotary axis combination to increase rigidity, as big of bearings as we can possibly get into that table unit. The bigger the bearing diameter, what we know is that the higher the rigidity, bigger bearing diameter, we want to carry that forward. The other idea that we carried forward were the braking systems that are on both the B and the C axes. Again, as large as possible, the biggest moment holding capacity that we can possibly fit into that machine. Now, one thing to note, the B and the C axes on the machine are direct drive. They're full contour capable, so they are live axes. But if you're going to do position and create feature or point and shoot style machining, we encourage you to position, clamp the brake, go about doing the machining when the B and the C axes are not moving. Just higher clamping rigidity as a result of that unit that, again, is built in standard on the machine. So one thing I want to point out, with the arrangement that we have to be cognizant of where we have machining access. If we think about a globe superimposed on the pallet of the machine, it's kind of a good, easy visual to think about. What you have machining access to from that globe perspective is anything around the equator up through the northern hemisphere. So that's your machining access area for workpieces in the machine. Very specifically, what you do not have with this kinematic layout is an undercut capability below that hypothetical equator. So just be aware of that. Makino has other products in our product lineup if that's important to you, if that's important to your process. But again, I just want to be very, very clear as to what the access capability is of this particular machine. Another design idea from our 4-axis platforms that carry over to the 500Z, true 3-point support. So the 3 points that I have located and shown on the screen behind me, those are the only touch points of the machine that have any effect on the leveling of the machine. Specifically leveling, not alignment. The alignment of the machine element to other machine elements that's built into the assembly of the machine itself, that's really an effect of the outstanding rigidity of the bed design that we use, maintaining those alignments. So when you do the installation, basically you're setting level on the machine. During the installation process, you are not aligning machine elements to other machine elements. We already take care of that at the factory for the life of the machine. So from an upside perspective to a customer, this reduces the cost and the complexity of your foundation. What we're really going to ask for is that those 3 points sit on one contiguous piece of concrete. We don't want to span an expansion joint. Get those 3 points on the same piece of concrete, and you'll be set for success. Also, this simplifies the installation of the machine. When you purchase an A500Z and Makino's field service engineer comes out to do the install process, that part of the process is very quick, very simple. Just setting level of the machine, not tweaking in machine geometry. Down the road, should you move the machine, it's very easy to move and relocate. But the biggest upside, again, based on the design of that bed casting, maintenance of the geometry of the machine itself, so no re-leveling is required as part of ongoing periodic maintenance. The Makino active thermal management system that we apply to our 4-axis machines also applies to the A500Z, with one subtle variation. Since the B and the C axes are direct drive, we know that they're going to be heat generators. So as is the case with some of the smaller 4-axis machines, we core cool the B axis. On the A500Z, we also take that same idea and core cool that C axis. So with the active thermal management system, the bed casting is a reference temperature. That controls the output temperature of the oil, the cooling oil, not lubricating, but cooling oil from the temperature control unit. In the case of the A500Z, that services the jacket that goes around the spindle. It services each of the 3 ball screws on the machine coming in through the non-driven side, out through the driven side. It pulls the heat of the movement of the ball screw out of the equation, pulls the heat of the dry motors also out of the equation. That system also services the B and the C direct drive axes. In that result, the machine in its standard configuration without scales, the accuracy of the machine is plus minus 2.5 microns. That is measured full stroke bidirectional, so a very difficult test. The repeatability of the machine in its standard config without scales, plus minus 1.5 microns. Now we do have some customers that insist on scales. From a demographic standpoint, typically this is going to be the customer base that's making ultra precision parts. Think of things like optics platforms, some of the machinery used in the semiconductor manufacturing process, things of that nature. Fitment of scales is an option on the machine. What it's going to buy you is plus or minus 0.5 micron better accuracy, plus or minus 0.5 micron better repeatability. So subtle shift, but again, to some industries, that subtle shift is very important to the overall stability of their process. From the standpoint of the rotary axes, accuracy is plus or minus 3 arc seconds, repeatability plus minus 2. A note on those come standard from the factory with a Heidenhain rotary scale installed in each of the rotary axes. That's the primary feedback mechanism. That's what contributes to the really high level of accuracy and repeatability of those axes. Moving on to cycle time efficiency, certainly something very important. When we think about a machine like this, gains in cycle time efficiency are really due to a couple of things. I mentioned already the rigidity of the machine, high metal removal rates as a benefit of that. But here I'm going to focus on the other side, the non-cut side, some of the things that we did from a machine design standpoint to really minimize that non-cut time. One of the things that all machine tool builders have to look at is management of inertia inside of a platform. So we know with any moving platform, any moving element within that machine, the lower the inertia, the easier it is to accelerate, the easier it is to decelerate, and the more accurate we can place that moving piece of equipment when we get to the point that we want it to be as part of that cutting process. So minimization of inertia is a really key foundation to the design of the A500Z along those lines. Again, I mentioned before that Makino has other 5-axis machines on our platform. I'm going to compare the A500Z to one of its siblings, the D500. This is a traditional trunnion style machine in the Makino lineup. Vertical spindle in this case, but a trunnion style machine nonetheless. One of the things that we've been able to do with the design of the A500Z, again, relative to a trunnion machine, is get the center of rotation of the rotary axes very close to the center of mass. As a result, we're minimizing that inertia. Again, if I use the D500 as the comparison point, the A500Z's inertia is 1/3 of that trunnion style machine's inertia. So that in and of itself enables very, very quick movement of the rotary axes on the A500Z. So if we apply that on a broader scale to the entire machine, if we look at things like the rapid rate, 60 meter a minute machine, a little bit more important acceleration. So again, A500Z relative to D500, almost 2 times the acceleration rate. But most importantly, it's a term in engineering that we call jerk. That's where we really see the benefit of the minimization of inertia. That's the portion of the acceleration curve, both on the ramp up side as you start the movement. At that point in time, you're going to achieve constant state acceleration. But on the back side of that curve during deceleration, that ramp. So the ramp on the acceleration side, the ramp on the deceleration side, those are the jerk areas. Those are where we really realize a benefit from the standpoint of that minimization of inertia design. So looking at a platform that we know, this is a test part that Makino's been running for 20 some odd years on a variety of different pieces of equipment. It's an optical box, kind of a general design, but a good test bed for what a 5-axis machine can do from a cutting capability standpoint, but also from a cycle time standpoint. Running that optics box on a D500 relative to an A500Z, the cut parameters are identical. So no change as far as the cut parameters go, but the overall cycle time is decreased. This is where we really see the benefit of the decrease of the non-cut time. The cycle time is 40% faster in the case of the A500Z relative to its sibling D500, no changes in the cutting process. So again, a really huge effort towards minimizing that non-cut time. A couple of the things that we do to the machine outside of the minimization of inertia, we also equip the A500Z with what we call inertia active control. So anytime we have a variable that's moving, think about this as payload. Pallet 1 payload may be very different from pallet 2 payload. What we can do with the machine when equipped with IAC like the A500Z is, we can minimize the amount of time that's used to accelerate and decelerate the Z-axis, the B-axis, and the C-axis, all those axes where it's payload that's moving around in the machine, by running a very simple interrogation routine. What it's going to do is it's going to measure the amount of current, in kind of layman's terms, measure the amount of current that's used to move the Z, to move the B, to move that C, and then pick the right acceleration curve for each of those axes that matches that payload. That's a interrogation routine that you do one time during setup, and then the machine carries those values forward anytime that given pallet is put back into a machine. Kind of begs the question, if you have a machine in a system, which the A500Z is compatible with the Makino pallet handling system or MMC2, a little bit more data flow, but during the interrogation, we'll assign those acceleration values to each pallet in the system as you run that interrogation routine. And then in that case of the MMC2, the cell control is going to manage that data flow. So anytime pallet 27, for instance, comes into the machine, the acceleration parameters that affect Z, B, and C also come into the machine. One other area that we apply IAC for machines that are fitted with the standard 60-tool ring style magazine, we also apply that to the rotation, speed, and acceleration of the ring itself. Very simple setup in that case. Anytime you open the operator door, service that magazine, maybe you take some tools out, you add other tools in. Once you close the door, put that magazine back into automatic mode, it'll do a quick self-interrogation and it'll set its IAC values for that payload that it sees now until the next time that you service the magazine. So again, applies to the ring style magazine, not to the matrix, but to the ring, and in a high production environment that can be very, very useful. Some other areas that, again, we build into the A500Z that minimize cycle time. Things like Makino's advanced motion control applied to drilling, or what we call GI drilling. As opposed to using a traditional path of drill, wrap it out, wrap it down, wrap it back into the R-plane, drill, repeat, repeat, for a canned drilling cycle, we'll round those corners going from hole to hole and basically cut out cycle time. It can be very dramatic. It depends on the hole pattern, depends on how many holes you're drilling within that pattern. But we've seen cases up to 30% faster cycle time for that same drilling process with the GI drilling enabled versus disabled, same cut parameters, same CNC program. Shifting the focus to the next area, reliability. All these things that I talked about that make a machine faster, if that machine goes down from a reliability standpoint, all the little incremental gains of efficiency that you built up over time with the cycle time efficiency, you'll lose that quickly if the machine is broken. And we have a very keen eye towards really maintaining a high reliability as we pull the 4-axis platform designs into this new 5-axis machine. One of the areas that's really important, spindle. The A500Z is available with 2 different spindles. From a volume standpoint, the high runner is the standard 14,000 RPM spindle with an option for a 20,000. Let me focus a bit on the 14,000 from the standpoint of demographic data. Now, this is the same spindle that we use in a variety of our CAT 40 class machines, including the current generation A51NX, A61NX, A500Z, of course, but the past generation A51, the past generation A61. So a pretty big population of machines in the market that we serve here at Makino Mason, being North America, South America, of machines that have this spindle style installed, which I'm going to show here in green. So if you look at that install base of all the machines that use that 14,000 RPM spindle, a pretty significant number of machines that are installed in North and South America. Some of these machines installed and running as early as 2005, so they can have a lot of hours on them. One of the things that I can track pretty easily is spindle shipments. Now, I don't know why somebody bought a spindle. I don't know why we shipped a spindle. It could be because the machine has thousands and thousands and thousands of hours on it and it's just time. It could be because the spindle got crashed, or it could be for whatever reason. But what I can show you is that shipment data relative to the install base. And if we look at that, again, year over year, what's shown now in red is how many spindles were shipped to service that install base. Very, very low consumption of spindles relative to the install base, running in that 3 to 4% area. So again, a very good indicator as to the reliability of that standard 14,000 RPM spindle, one of the areas that we pay a lot of attention to. Other things that are very important from a reliability standpoint, it's important to not only have a fast tool change system, but also one that's highly reliable. The things that we do to enhance that reliability, very simple mechanism, auto lubrication standard, oversized bearings, all the things that we can do mechanically to really maximize that reliability of that system. But I'm going to give you an example of devil's in the details, something that's seemingly as simple as the shutter door that separates the machining side from the tool magazine side that's going to open and close every time you do a tool change. Some of the data that we have been given by customers that use our machines, in a production environment, it's not abnormal to see 2 million tool changes a year. So think about that shutter door, that's 4 million cycles of that shutter door in that scenario, opening, closing. Something that, again, if it's broken, that machine is down, you're not generating revenue. So instead of the very normal use of a pneumatic cylinder to open and close, Makino instead on the A500Z as well as our other NX series machines uses a combination of a ball screw and a servo motor. Some people when they first see this think, well, that's kind of overkill. That seems a pretty expensive way to open and close a door. And on the surface it is. But if we think about things from a reliability standpoint and that machine staying in production, that additional expense up front really begins to pay for itself very quickly. So again, going back to the comparison of the pneumatic cylinder, pneumatic cylinders bounce off a cushion at either end of their stroke. That's just the design that's inherent with them. So if you think about that door opening and bouncing off of that cushion, it's going to have some oscillation in it. On the opening side, same thing on the closing side. With the servo-driven system, instead, very, very smooth motion of the door. You keep that physical, mechanical stress out of those moving elements. It really enhances reliability. Kind of another upshot of that, since it is in effect a programmed access now, we can open that door only as much as is needed to get the bigger of the two tools either into or out of the machine based on the data for that tool that's in the tool detail screen. Really doesn't affect cycle time, to be very honest with you. It's more of a minimization of the opening between the dirty side of the machine, the machining chamber, and the cleaner side of the machine, the tool magazine. But again, an inherent capability of the system that we use. Also in reliability, axis covers. Very simplified design continues to be used in the A500Z, a combination of the single piece covers for the Z axes that Makino pioneered way back in 2001 with the original A51. We continue to use that. It's been very, very successful from the standpoint of minimization of repair costs for our customer base. For the X-axis cover, a simplified two-piece design. For the Y-axis cover, it's a segmented cover, but with pantograph arms on the inside to control the movement of each element of that Y-axis cover relative to its neighbors. Coolant is very important from the standpoint of chip management. A variety of coolant systems are standard on the machine, including things like terrace washing. What that is for any surface that's not completely vertical, we're going to run coolant over it to knock that chip buildup that otherwise would happen down into the center trough of the machine and back out through the rear-mounted chip conveyor. Vision broken tool sensing, standard on the machine. What this is going to do, it's not a tool setting device, but what it's looking for is a gross deviation of the tool from the standpoint of what the tool length was that's registered in the tool detail screen relative to what it's seeing, what it's sensing, either prior to that tool going into the machine, after the tool comes out of the machine, or the combination of the two. You can set it up however you'd like. So think about the use of this for a tap drill tap scenario. Tap drill checks good at the end of its use. We know that the holes are there so that the tap that's going to follow them actually goes into a hole instead of something that didn't get drilled because the drill broke. Conversely, you can also use that on the backside of the tapping operation. Make sure that tap is still in one piece, that it's still good prior to you shipping that part to your end use customer, only for them to find out that a variety of holes that were drilled never got tapped because a tap broke somewhere in the production process. Very useful. I want to close out with just a couple of other considerations in the design of the machine. Access to the workpiece, both on the pallet load station as well as in the machining chamber. Very large opening doors, very easy to get at the workpiece. And think about that applying particularly at the pallet load station, not only to somebody going to the front of the machine to interface, but also when that machine is put into a robotic loaded cell. One of the things that Makino pays a lot of attention to, because we know automation is so important to customers, very wide opening of the doors on the front side of the machine, and a great deal of symmetry of the opening width of the right-hand door to the opening width of the left-hand door. Again, trying to make things very, very easy from the standpoint of interfacing automation. The ability to integrate the machines into a robot loaded cell through the addition of retrofit options like auto doors on the front of the machine, coolant wash, things of that nature, a robot interface, all designed and available as retrofit options on the A500Z. And then also the ability to interface the machine into our pallet handling system, the MMC2. One of the things I noticed, or I mentioned way up front, the compatibility of the work zone between the A51NX, its work zone diameter, and the A500Z. The reason being that that's important, we can put both of those machines into the same MMC cell. Now, if you're familiar with the A51NX, you may say, hey, wait a minute, that's a 400 millimeter pallet machine. The thing that makes them compatible is the cone spacing on the bottom side of the pallet. The cones that we use to clamp the pallet in the machine, they're the same cone spacing between a 51NX and a 500Z. So the 500 millimeter surface pallets in the 500Z with the 200 millimeter cone spacing are usable not only in the 500Z, but also in the 51NX. They can live in the same MMC cell together. Pallet magazines are also available as options on the A500Z in either a single, a dual, or a 3-level setup. So 7 pallets, 14 pallets, or 21 with one workset station. Again, another form of automation that plays in certain areas of our geographic area that we serve. So let me talk about the equipment that comes standard on the A500Z. One of the things that we do at Makino when we introduce a machine to market, we want to have that machine in its most basic format without selecting any options at all, able to actually be installed and be used in a production environment. So with that said, it starts out with the spindle. The 14,000 RPM spindle with the Cat 40 interface is standard in our market. 60-tool magazine, standard in our market, as well as the pallet changer. From a competitive standpoint, a lot of the machines that the A500Z competes against, that pallet changer is either not available or is an option. On the Makino platform, it comes standard on the A500Z. From a control standpoint, it comes standard with the Makino Pro 6 control that's based on the FANUC 31i platform. Our Super Geometric Intelligence contour machining control as well as collision safeguard are both standard on this machine. Typically, you're going to see SGI and CSG as options on a 4-axis machine. In the Makino lineup, those come as standard on the 5-axis A500Z. We elected also to make the Renishaw touch probe standard on the machine, combined with our center of rotation axis measurement software. The CRAM software is used on a recurring basis, basically defined by your manufacturing process to interrogate that machine, make sure that grid shifts and things of that nature are all staying where you need them to be to support your manufacturing ideas. The chip conveyor that comes standard is a single layer. That is fitted with not only a drum coolant filter, so that's going to turn dirty coolant into clean coolant, but then beyond that, cyclonic coolant filtration that turns that clean coolant into super clean, the super clean coolant being used to service the through spindle coolant circuit on the machine, as well as some other critical areas. Standard coolant, 320 psi through spindle, the nozzle coolant around the perimeter of the spindle, the shower coolant from an overhead perspective, and the base coolant, as well as that terrace wash that I talked about before, the vision broken tool sensor standard, as well as active thermal management, all standard on the machine. And then the last item, transformer, standard on the machine. Very, very comprehensive. Just from a high level perspective, some of the available options on the machine, the 20,000 RPM spindle, HSK A63 spindle interface. If you buy the 14,000 RPM spindle, the HSK interface is an option. If you buy the 20,000 RPM spindle, that HSK interface is the only interface that we're going to supply on that 20K spindle. We have optional tool magazines all the way up to 313 tools. The option for the glass scales on the X, the Y, and the Z linear axes, a Renishaw laser tool length measuring system, a dual layer chip conveyor for high volume generation applications, 1,000 psi through spindle coolant, typically in the form of a chip blaster HV40, coolant temperature controller, mist collector, and a variety of automation support options for both that direct part loading scenario that I talked about, as well as the alternative of putting the machine into the MMC2 pallet handling system. So that's an introduction to the A500Z. What we'd like to do now is open this up to any questions that you might have, and we'll address those on a one-by-one basis. Thank you.
All right, we do have a couple of questions that have come in today. First and foremost, thanks for taking some time to listen to the description of the A500Z, but let me address the two questions that I've got in front of me at the moment. First question, you talk about the A500Z in an MMC cell. Can you do that insertion of a 500Z that's initially used as a standalone machine into the MMC somewhere down the road? And the answer is yes. Very much like our NX Series 4-axis horizontal machining centers, the A500Z can be converted from a standalone configuration to an MMC configuration anywhere down the line. The same comment would apply to taking a standalone A500Z and using it in a robot cell. Things like auto doors, fixture wash, those can all be added to that machine down the road after it's initially used as a standalone. So the next question I have in front of me, is there an A500Z in your showroom that I can see operate? The answer is yes, twofold yes. Number one, we have one installed here in Mason, Ohio, in the greater Cincinnati, Ohio area. That's our main location here. We also have an A500Z that's available for demonstration up in our Auburn Hills, Michigan showroom. So 2 A500Zs installed in Makino facilities. Contact your Makino sales person if you'd like to get a demonstration on either of those machines, and we can certainly facilitate that. At this point in time, that's all the questions I've got in front of me. If anything comes to mind down the road, please feel free to reach out to me. More than happy to take those questions offline. I can be reached at john.einberger@makino.com, or you can do it through my phone number at 513-573-7380. Thanks again for joining us today, and we look forward to talking to you again soon. Thanks.